This is a solution to 2015 Q2b that I gave you for Friday. So we were told that a woman, falls with a speed of 5, so her speed is minus 5j, and then as she falls, the wind hits her, or the rain hits her, such that the angle that the rain hits her at is 45 degrees. So all objects fall with acceleration due to gravity of 9.8. So what that's telling me is that the rain is falling at that speed, and in order for this to work, the lady probably has the parachute out. So she is traveling slower than the rain, or the rain is traveling faster than her, or the wind is traveling faster than her, whatever the question says. So that means that she thinks the wind or the rain is coming down on top of her like that. So the velocity of the wind relative to the woman has to be down like that rather than up. So she's never going to experience that the rain is traveling up relative to her, because she's not traveling faster than the rain, basically. So we know the speed of the rain. We have the angle. If that's 45, that's 45. Use cos to get the I component, sine to get the j component, and we get that. It's in the third quadrant, hence the minus and the minus. Then when she slows down to 3 going downwards, the angle between the vertical works out as 30 degrees, and we know that the speed that she experiences the wind or the rain at has to change, so I'm using y there. That's 30, that's 60, cos for the I, sine for the j will give you that. All right. Then we know that the relative velocity vector is given by that equation. Rearrange it, the velocity of the wind is given by that equation. It's basically add the two of those together will give you the velocity of the wind, or add the two of those together to give you the velocity of the wind. I did that, and I know that the velocity of the wind is a constant, so we can equate the i's with the i's and the j's with the j's. Equating the i's gives us that relationship between y and x. Equating the j's is that, and instead of y, I put in the root 2 over x there. Then it's a case of solving for x, which I've gotten here, and then if I put that x value into this equation here, which is the velocity of the wind, that gives me the velocity of the wind in ij form, which I've simplified to that. Now, I really should have simplified the right-hand side, but I didn't. I went through it really quickly. Once you have that, then get the magnitude, which is the square root of that squared plus that squared. Get the direction, which is that one over that. And what ends up happening is you take a common denominator between the top two terms, gives you a denominator there of root 3 minus 1. The denominator on the bottom is root 3 minus 1. Flip that upside down. The root 3 minus 1s cancel, and you end up with this thing. So when you work that out as a decimal and then get the inverse tan of it, you get 19.5 roughly.